Alright, so example 10 now. Hopefully we can finish up here, section 1.1. Just some basic equations in trig, just to summarize everything that's going on. Solving this one now. Just like I said before, get roots. You want to get all the roots all alone, all by themselves. So to get this root all by itself, I'm going to have to add 4 to both sides. And when I do that, the 4's cancel out, so I get the cube root of x equals 4. And to get rid of the cube root, remember, that's like saying x to the 1/3. So to get rid of that, I need to somehow make that exponent of 1. That's why the opposites of a third would be a 3, because 1/3 times 3 cancels out. Just like the 4th root would be the 4th power, the 5th root would be the 5th power, and so on. So a third root, I take each side to the third. So those cancel out, and 4 to the third is like saying 4 times 4 times 4, which is 64. So you get 64 as your answer. In this problem, it's all about the reciprocals as well. So because that was a 1/3, that's why we took it to the 3/1 power. That's why I showed you 1/2. You would take it to the 2/1 power, right, in the last examples. Now with this, before we can do anything, just like any other problems, we have to get x by itself. So it's 2 times all of this. So I'm going to divide both sides by 2 to get rid of that 2. So I got x to the 3/2 equals 125. Not a problem. Except, how do you get rid of this? Well, once again, you need to take both sides to a power that will end up canceling out and making this 1. Here's how it always works. It's the reciprocal of whatever the exponent is. Just like x squared, what do you do to get rid of an x squared? You square root both sides. Well, when you square root both sides, the square root is like saying 1/2 to the half power, right? It's something to the half power. Well, what's the reciprocal of 2? 1/2. That's why they cancel out. Opposite of cubing something is the cube root, and the cube root you rewrite as 1/3. So once again, it's all about reciprocals. 3/2, what's the reciprocal of that? That is the 2/3 power. So what that means is I need to take it to the 2/3 on both sides. Got to do the reciprocal of each. So now that cancels out, and I end up with x to the 125 to the 2/3, which I can rewrite that by pulling that 2 out. We talked about this in the prerequisite section, and the reason why I pull that out this way instead of the reverse is I can do 125 to the 1/3 in my head. Can you think of a number 3 times that gives you 125? I can. 5, right? So really I'm saying, hey, what's 5 squared? 5 squared is 25. So your answer to example 11 is 25, or you could have just plugged that in a calculator from the start, 125 to the 2/3, and you would have gotten 25 as your answer.
Kid, you tried your best, and you failed miserably. The lesson is
Never try, yes. So there we go. So there is the homework. It's in the book. Take a look at it. If you have any questions, feel free to email me. I hope that this was helpful. This summarized a whole bunch of basic equations that you've ran into ever since you've done algebra. There's more than just this. Of course, I know there's more than just this, but hopefully this was enough to kickstart you and get you started. So we'll also have some examples in this section as well, and I hope that those examples are helpful to you. If you have any questions or concerns, please feel free to email me at any time.